Today we're going to learn about solve by substitution. Solve one of the equations for a variable, substitute and solve 2 times, and write as an ordered pair. So in order to solve a system of equations, you need to use substitution. This is going to be very important, so make sure you pay attention in this video. So the first step is to solve one of the equations for a variable. And let's just start with the first one. In the first equation, we've already solved for y. Y is equal to 2x. So what we can effectively do is substitute the value of y into the second equation. So what we're doing is we're taking this equation and plugging in the value of y into the second equation. What is y? Y is equal to 2x. So we can write 2x here instead. It's the same thing, which is going to be equal to 10. Now we can add these together and we get 5x is equal to negative 10. Divide by 5 and we get x is equal to negative 2. Now we're not done here yet. We still want to solve for the value of y. So right now we've substituted and solved once. Now we need to substitute and solve one more time. So we take this value of x, plug it back into the original equation for x. So we get y is equal to 2 times this value here, which is x, which is negative 2. So we're going to get negative 4. So our end solution is y is equal to negative 4. So as you can see, the point of this is to figure out a solidified value for x and y. We got x is equal to negative 2 and y is equal to negative 4. You can plug these numbers in the original equations all you want and the equations will make sense. So now we write this as an ordered pair. We write it as negative 2, negative 4. This is the point to which the two linear equations intersect. Now for the second problem here, we have to solve one of the equations for a variable. In the first problem, we are given the value of y. But in the second problem, we're not given the value of one of the variables. So if we subtracted 3y from both sides on the first one, we're going to end with x is equal to negative 3y plus 6. So now because we have solved for the value of x, we can now plug it into the second equation. 7 times negative 3y plus 6 minus 4y is equal to negative 58. This simplifies to negative 21y plus 42 minus 4y is equal to negative 58. Subtract 42 from both sides. We are going to get 21y minus 4y is equal to negative 100, which is going to simplify to negative 25y is equal to negative 100. So we can divide both sides by negative 25. So it's going to be y is equal to 4. Now again, we're not done yet. We have to take the value of y and we can plug it back into one of the equations to solve for x. So let's do the first one. We're going to get x plus 3 times y, which is 4, is equal to 6. So we're going to finally get x is equal to negative 6. As an ordered pair, this would be 4, negative 6. So this is our final ordered pair. Now this last problem is a little bit tricky here. We have the value of y. So let's plug that into our second equation. We're going to get negative 6x plus 2 times 3x plus 6 is equal to 12. This simplifies to negative 6x plus 6x plus 12 is equal to 12. These cancel out, so we get 12 is equal to 12. So what do we do now? We have 12 is equal to 12, which is true, of course, but we can't do anything further. Well, when you get 12 is equal to 12, or any number is equal to any number, this basically means that these two equations here are the same line. And so there's an infinite number of solutions. If you look carefully, multiplying this first equation by 2 would actually result in the second equation here. So that's why they're the same.